my name is Zakaria Gali Anak Peter, metric number 72029. I would like to present my part, which is the engineering problem. Engineering problem, solving and creating a PV diagram for Otto cycle. In 1876, Nicholas Otto built an internal combustion engine utilizing the four-stroke cycle, four-stroke of the piston for each ignition. The four-stroke cycle was patented in 1862 by the French engineer Alphonse Biot de Rocas, but since Otto was the first to build an engine based upon this principle, it is commonly known as Otto cycle. Because of its reliability, efficiency, and its relatively quietness, Otto's engine was an immediate success. Advantages of an Otto cycle engine: relatively good thermodynamic efficiency, inexpensive to maintain and build, excellent power-to-weight ratio, and good reliability. Drawbacks: it requires more moving parts and manufacturing expertise. Engine is usually larger, heavier than two-stroke engines or rotary engines of comparable power output. Conclusion: the Otto cycle continues to be an integral and effective combustion cycle amongst many engines because it provides excellent efficiency and power output. By using the code our group has created, it can save time of the analysis and research as we can just plug in the values we need in the code. Engine specification, minimum temperature, maximum temperature, and intake pressure are the values that needed to be input in the code for it to work. It will then generate the answers and can create a PV diagram for the Otto cycle. That is all from my part. Thank you.
Hello, my name is Jason Wong with the metric numbers 69929. This is the algorithm for our project to solve and create the PV diagram of Otto cycle. First, we start the program of the MATLAB. Second, put the constant as gamma equal to 1.4. Then third, input the magnitude of ball stroke, connecting rod length, compression ratio, minimum temperature, maximum temperature, and intake pressure. 4. Based on the ideal gas law, find the pressure, temperature, and volume at each point based on the relation. Then 5th, plot a graph of pressure vs volume. 6. Display a table of row 1, 2, 3, 4 and column pressure, temperature, volume, and depressed efficiency. The 7. Display engine is square engine if ball divided by slope equal to 1. Display engine is over square engine if ball divided by slope is more than 1, and display engine is under square engine if ball divided by slope is less than 1. Then 8. Run the programming code if want to analyze again. Then 9. End the program.
Good day, I'm Ui Ting Lin with matrix number 71273. Today I'm going to talk about flowchart and pseudocode. A flowchart is simply a graphical representation of steps. It shows steps in sequential order and is widely used in representing the flow of algorithms, flow of processes. And each shape used in the flowchart represents different meanings. Each circle represents starts or end the program, rectangle for steps or perform a task, diamond is used for decision, parallelogram is used for action, and flowline is to connect the flow in ordered way for completing the flowchart. To begin with the flowchart of the Otto cycle, initiate drawing a circle to start the program. The value of gamma is 1.4 is fixed, so it is located in rectangle. For the next action, which is parallelogram, to input the values of ball, stroke, connecting rod length, compression ratio, minimum and maximum temperature, and intake pressure. States 1, 1 to 2, 2, 2 to 3, 3 and 3 to 4, and 4, by using rectangles as they are performing the task and calculations, which states 1, 1 to 2, 2 to 3, and 3 to 4 are the transitions during the changing of states. After all the values are calculated, the graph of pressure against volume is plotted and parallelogram is used. Parallelogram is continued using to display the table of row and column as well as the efficiency. Here comes the decision making. So diamond is used. If the ball stroke equals to 1, the output will display engine is square engine. If it is more than 1, it will display engine is over square engine. If it is smaller than 1, it will show engine is under square engine. After that, parallelogram is used to display. Do you want to analyze again after the previous decision making is done? If yes, it will start all over again, but if no, the program stops. Pseudocode is an informal way of programming description that does not require any strict programming language, syntax, or underlying technology considerations. It is used for creating an outline or a rough draft of a program. Pseudocode summarizes a program's flow but excludes underlying details. First is to start the program, and number 2 is to perform the task for gamma is 1.4. By inserting the values from number 3 until number 9 for the calculations of number 10 to number 28, which varies in different states to run in the program. Graph plotting and labeling of x and y axis for the graph are the next steps after finishing the calculations, which are starting from number 29 to number 38. Visualizing the table of flow for 1, 2, 3, and 4, and column which are volume, temperature, and pressure, and display the efficiency of the engine starts from number 37 until number 43. If the ball stroke equals to 1, the output will display engine is square engine. If it's more than 1, it will display engine is over square engine, and if it is smaller than 1, it will show engine is under square engine. The program will stop after that and display do you want to analyze again. So if yes, it will start from the beginning, but if no, the program will start and end of the program.
Hi, my name is Marisha binti Adris, metric number 70881, and I will be presenting about the MATLAB code and the output. So here we have the script file for the engineering problem. We started off with the while loop on infinity, and then we have the constant, and then we have the engine properties where we can input the engine properties based on our problem. And then we have the program where we can calculate all of the properties on the other points, such as P2, T2, P3, P4, T4, the efficiency of the engine. As you can see here, we have the V compression, V expansion, and P expansion. So these four properties we calculated with another script file, which is the piston kinematics function file that could help with the calculation. And then we have the plot the graph MATLAB code where we can plot all of these points on one graph. And then the next code is where we can see the output of the analysis, where we can see everything. And then we have the loop where we'll be asking if we want to analyze again. It will break if we answer N for now. And now we will try to input all these properties into the command window to see how the output will be based on the program. Okay, so now we will run the Otto cycle script file, and then we will input all the properties of the engine, based on the previous slide. So after we input all of these engine properties, the MATLAB code will calculate all of the other properties and put it into one table where we can see the pressure, temperature, and volume of each point 1, 2, 3, and 4. And then we will have the efficiency of the engine, the type of engine, and then the code will ask again whether if you want to analyze again. So in this one, I put N for no, and then we can see here the figure of the calculation that we have made. So this is a closer look on the command window input and output. On the left we have the command window user input where they input the engine properties, and on the right is the command window output where they've shown all of the properties of the engine that has been calculated. So the MATLAB code also shows a plotted graph output, which is shown in this slide. The figure will show a PV diagram of the calculated properties. We have reached the end of our video presentation. Thank you for listening.